Welcome in to another new AMP podcast. My name is Ben Dubose, your host, and I'm the news editor with AMP Publications, where I create content for both Coatings Pro Magazine and Materials Performance Magazine. On today's sponsored episode, we're happy to be joined by William Seawell, best known as Bill, and he's the technical service manager with Induron Protective Coatings. And alongside Bill, we have Andy Odorzynski, national sales manager at Induron. Founded in 1947 and currently based in Birmingham, Alabama, Induron manufactures high-performance coatings to serve a wide range of industrial applications. These applications include industries such as wastewater, electrical transmission and distribution, and potable water storage and treatment. So first things first, can each of you introduce yourselves to our audience and tell us a little bit about your career journeys to this point? Bill, we can start with you.
Yeah, sure. Like you said, my name is William Seawell. Most people that know me call me Bill. There's not two guys out there working for Induron. It's just me. I went to the University of Southern Mississippi and majored in chemistry. I'm from Hattiesburg, Mississippi. It's a Hattiesburg school. Graduated and decided wanted to find something to do in the chemistry world. Ended up in paint. Worked for a different manufacturer for a while, and then here we are at Induron. I'm the director of technical service. Deal with some of the R&D related stuff and some of the salesy stuff as well. Andy is a better talker than me, but I talk well enough. And that's probably a good transition for Andy.
Yeah, I'll dive in there. My background started in the field. I started a painting apprenticeship right out of high school and worked as an applicator for years and got the opportunity to work for a tank fabricator and builder based out of Louisville, Kentucky. And that's what really brought me into the tank side of painting. And that's really where I've spent my career. So protective coatings is kind of the only thing I've done with my adult life. That's what I spend all my time on. And a lot of that focused specifically on the water tank market. And in my time at Induron now, working across all our markets to help grow sales, work with owners, engineers, and contractors.
All right. So in the second half of last year, Induron published a white paper with Materials Performance titled Questioning Our Assumptions About Primers and Immersion Service and Their Place in the Water Industry. In short, that paper looks at the various technical reasons behind the common engineering beliefs related to galvanic mechanisms in organic urethane zinc primers and why some of those should be re-examined at a systemic level. That's the topic we're going to dive into on today's podcast. And if you want more details, you can just go to www.materialsperformance.com/white-papers and download it for yourself. As usual, we want this to be a free-flowing roundtable conversation, so each of you can jump in with an answer whenever you see fit. So let's start with the basics. With water tank primers, the phrase is somewhat self-explanatory, but can you give us some context for what a water tank primer actually is and what a water tank primer is expected to do?
Yeah, this is Andy. I'll dive in on that one. I mean, first and foremost, with primers, what we want to happen is they need to stick, right? Depending on exactly what we're painting, be it a tank or something else, there can be different surface conditions there, other coatings there, and what we're trying to maximize with primers is getting adhesion to whatever we're coating and allowing a substrate then after it's primed that the subsequent coats can stick to. So there's a little different answers when you apply that to tanks. One, when we're thinking about rehabs, we need things that are going to be very flexible to work with in the field in multiple weather conditions. We're going to have different levels of prep where sometimes there's spot priming, sometimes there's full blast removal, and that can be to varying levels of cleanliness. So we have a wide range of substrates we might need to stick to when we're doing rehabs. And on the new tank side, there's even a little bit of an extra wrinkle there because very often those are shop fabricated. So we have this large gap of time that can happen between the original primer application and fully erected and complete structure. And the primer gets this extra role of preserving your surface preparation and making sure that the steel stays in good shape and ready for subsequent coatings over that extended period of time between initial prep and field application of coating. So the main answer is we want to add protection and we want to stick like crazy when we're dealing with primers. And you can contrast that with some other coatings, like if we had a UV protective coating, we may care more about the resistance to UV, the protection from the sun. So adhesion is not what we're bolstering with additives. And you can only fit so much in that can. So with primers, your real choice is to go after adhesion and make sure you've got something great for those subsequent coatings to stick to.
As a quick follow-up to that, Andy, let me jump in real quick. just to clarify for our audience, so Induron is a coatings manufacturer, but as you mentioned, you guys are also very involved with application phases at projects. You guys are sort of a unique company in that certainly you are a manufacturer, but you're very tied in with the end application in many cases as well. So you have a very sort of unique understanding of both sides of the value chain. Andy, can you speak to that a little bit, just the role that Induron has in some of these projects that you're speaking to?
Yeah, absolutely. I appreciate you sharing that. That's certainly how we come to market, right? Our role, as we view it, is to have innovative technology to be an engine of growth with the technology side of the coatings industry. But the only way to deliver that is at the job site, right? The rubber meets the road where somebody is opening these cans, mixing these products, and applying them. And if you want to deliver great technology there, you got to be there. So we are, at our core, believe that we have to be at the point of application, working with the people putting our products on. And honestly, that's so true that it's the main backbone of our R&D process. You know, we view our ability to differentiate largely revolving around the ease of application and what we can do in the field to make this stuff easier to do for folks. So yeah, point of application is super important for us, and we make it a specific point to be on the job site, not just on the phone.
So we talked about the basics of water tank primers. Let's talk about zinc primers specifically and how those fit into the water tank coatings market. What are some of the benefits of zinc primers when it comes to both a coatings applicator as well as for a client that owns a tank?
In a lot of ways, depending on who you ask and how old they are, it could be argued that zinc primers are the traditional option or zinc primers are the new option. It sort of depends on your context here. So tanks have been painted and primed for a very long time, obviously, all the way back to Cosmoline liners and things like that. Fast forward to, you know, the late 1900s, a lot of these are primed with epoxies and similar technologies. Zincs show up on the scene though. And these zinc primers are moisture cured urethane isocyanate primers that are filled with zinc. Now, the claim is that they galvanically protect the underlying substrate. That is true with large caveats. And that's sort of the theme of the white paper, if you will. So let me break it down to just sort of first principles. Not everybody is a water tank paint nerd and keeps their nose in this all day long, but everyone is familiar with galvanized steel, right? Just regular carbon steel that's been hot dipped, galvanized, coated in zinc. That zinc protects the underlying steel by sacrificing itself electrochemically, preferentially to the steel underneath it. People that are involved in pipe or marine stuff see this as well. Sometimes you'll have active cathodic protection where you're actually impressing current, doing the same thing, or passive anodes like zinc and magnesium. That's what these zinc primers are doing. The new tank process is very shop heavy. So a lot of the steel is fabricated in shop and primed with zinc primer. That zinc primer exposed to the atmosphere on that steel does protect the underlying steel very effectively when it's shipped to the job site. At some point, that tank is going to be erected, top coated, and put in service. And our white paper sort of deals with that transition right there. Something fundamentally different happens when zinc gets top coated. But in short, the 30,000 foot view of zinc primers is they're galvanically active primers that protect carbon steel, full stop. That's what they are. But there are multiple ways to do that. And basically what we're here today to tell you guys is you can prime a tank a lot of different ways. A lot of these ways are valid. Zinc, in fact, is a very valid way to prime a tank, but there are other valid ways as well. And that's where we get to the questioning our assumptions part.
Before we get to questioning the assumptions, I also want to do a high-level overview of epoxy primers, as you mentioned in your previous answer there. How are epoxy primers different from zinc primers in a technical sense? And are there some advantages to epoxy relative to zinc?
Right. Epoxies are an old technology. They're a very old technology.
Right.
And they're the same technology that's in the JB Weld that everyone's familiar with. Very hard, very highly cross-linked, very robust films. So zinc's mode of action in protecting the underlying steel is galvanic sacrifice of its pigment package, zinc. Epoxy works in a very different way. It's all barrier. We sort of have a joke internally. It works by being there. And that's really the deal. You have a very tightly cross-linked polymer film. Oxygen cannot penetrate to the underlying steel, can't form iron oxide. The entire electrochemical process is kind of cut right there. Depending on who you ask, you need 5 or 6 things to operate a corrosion cell. You need an oxidizer, which is oxygen in our atmosphere. It's everywhere. You need an anode, which is the steel that's going to be corroded. You need a cathode, which is the surrounding steel. You need an electrolyte. Some people would argue you need a conductive pathway. That's the steel itself, whatever. That's a bookkeeping issue. But epoxy stops corrosion by interrupting that process. I think it was the third one I said. When the oxygen can't get to the steel, there's no corrosion happening. The chemistry just can't proceed. That's how epoxies work. And as you can see, it's very different than zinc. Both methods are valid, but it's a very different mode of action.
So let's go into the white paper. In that paper, you all discuss at considerable length the electrochemistry of zinc and iron and how that can drive the underwater corrosion processes in water tanks and how zinc may or may not prevent that. Can you explain some of that here and flesh out those considerations a bit?
Sure. And we already touched this a little bit when you asked me about zinc primers, but
right.
Imagine we're on a shop, right? And we have freshly blasted steel, usually SSPC SP10 steel. A side note, in the white paper, we're specifically talking about tank primers and immersion. So tank interiors. This is somewhat relevant to exteriors as well, but very relevant to interiors. So just, for your listeners, we're restricted to linings here. But we put zinc on the steel, and that zinc is able to interact with atmospheric oxygen around it, right? In order for the zinc to protect the steel, an irreversible chemical process must take place. Zinc must meet with oxygen or water to become zinc oxide. When zinc cannot do that, when it's physically prevented from doing so, that chemical reaction cannot proceed. It's really quite simple. Conservation of matter. Oxygen atoms do not appear. A zinc atom must touch an oxygen atom to create a zinc oxide salt. So in the white paper, we point out that there's a host of academic literature that sort of points this out. A lot of different electrochemical experiments show that this galvanic process does cease in very short order once the zinc is top coated. So what we're saying is zinc does sort of work in the sense that it will protect your steel galvanically before it's top coated. But once it gets top coated, your top coat is the thing doing all the work. We believe strongly, and it's not really a belief, it's a matter of scientific fact, that zinc is not galvanically active in immersion after it's been top coated. I say there's a lot of academic research on this. There is, but there's not as much as one would think, given the commonality of zinc primers in tanks. We don't believe the science was terribly thoroughly agreed upon prior to zinc appearing in the spec literature. And we say this as a company that sells moisture cure urethane zinc primers and still do, and we don't plan on stopping. They do work. They're just not galvanically active, top coated in immersion, full stop.
So technically speaking, what are the factors, what are the properties that you're looking for in a water tank primer? You've addressed this a little already, but getting a little more specific, a little more technical, what are the properties that an asset owner is looking for in a water tank primer?
So a primer, and Andy touched on this quite well, and that's why I sort of passed on the point earlier because Andy kind of already got to it. A primer is a facilitator for the rest of the coating system, right? So a primer must necessarily be there to facilitate subsequent coats sticking to it. However, at Induron, we believe the majority of the work should be done by the liner and by the barrier properties of the liner. So an ideal primer must have sufficient adhesion to stick to the substrate, sufficient adhesion to stick to the top coat, and it should not have any property that can compromise the performance of the lining. We do not believe the immersion primer properties in the dry film should be the thing driving the bus on the spec. The primer should not inhibit the installation of a lining system. If it does so, it's a bad primer. If it does not, it's an acceptable primer. And that's the way we do it.
I'll add a little context there as well, because I think while we're discussing these technical aspects of coatings performance, there's another piece to this story with how things have worked for applicators in the field, right? So one of the other changes that came along with those historic epoxies that Bill mentioned and the transition to zincs around the turn of the century, these urethane zincs on water tanks, had also a lot to do with where those moisture cured urethane resins sped up the applicators, right? So one of the things that transitioned here, put yourself in a time machine, you had your paint rep showing up and saying, I've got this new zinc. It's twice as much money. And it contains isocyanates and some other stuff you might not love. Well, why did everybody adopt these things? One of the answers is it's fast. It dries quick, right? So they were able to get this steel primed and move through shops quickly. They were able to get it applied in the field, and they liked those production gains. So even though there were some things that we didn't like quite as much, at the end of the day, money talks. And when production gains can save labor, it means a lot. So a lot of people made a transition to zinc, not on the basis of any galvanic protection or technical long-term performance argument, but simply because once it was a spec option, it could speed up their throughput and get these jobs completed and billable faster. And while we're spending a lot of time focusing on the technical attributes of protection here, I think one of the reasons this whole conversation is enabled now is the epoxies catching up in that sense, right? As we start to manufacture epoxies that can be faster, have longer recoat windows, and match all those characteristics for applicators, and then we start to look at these technical reasons of why they were chosen in the first place, with both directions come together with a pretty interesting picture of like, wait a minute, why are we using these things, right? If we can match those money metrics and be fast in the field, and the technical argument no longer seems to hold water, it just seems like a good time to stop and ask ourselves, why are we paying twice as much for these zinc primers in 2024? So, in addition to all the technical points Bill made that are fantastic, there's also a lot being driven by ease of application and speed in the actual field application of these primers.
Your white paper points out a few times, and of course you've made the arguments in our podcast today as well, that so many of the common understandings of how the zinc-based primers function are incorrect. Is the implication then that zinc primers aren't suitable for water tank use at all? Just explain, I guess, the lines there, and just at a general level, do zinc primers work?
Yeah, thank you for asking that. So we can be abundantly clear. Induron sells MCU zinc primer. Ours is called Zinc 67. We hope you buy some today. They do work, but based off what Andy just said, if we run down the list of check boxes for a primer and immersion, what do we need? Well, we need fast, okay? We need a long recoat window, okay?
Mm-hmm.
We need acceptable adhesion, okay? We run down that checklist, people would go, wow, it would be great to have a technology type that's not zinc, that doesn't have the isocyanates, doesn't have the application problems and coupled to humidity cure and all that. It would be great if we get all those properties and some other technology. We're here today to tell you that it exists. Polyamide epoxies do that. They do all that, and we know how to do it. It's not we're not bringing a new technology really, in the sense that this is not a new resin. This is nothing fancy. This is good old fashioned epoxy. It is in AWWA D102 as is. I believe the ICS 1 and 2 systems, at least, if not more, are epoxy primed. This is the traditional solution, and I think I mentioned earlier that depending on who you ask, zinc is the traditional option or the new option. We're kind of going back to basics here. We believe all the scientific evidence points to the fact that barrier properties are driving the bus as far as longevity goes. There's a lot of real life studies to back this up, and we think if we have all of the things even, you should go for the barrier properties, and that's sort of our theme.
So that explanation is pretty straightforward. It's intuitive, but that's not the normal technical messaging that you generally hear from paint manufacturers when it comes to the use of zinc primers in this context. How did you all come to this understanding, and how did the broader coatings and water tank industries come to that understanding when it comes to zinc primers and their use in this application?
Andy and I have a joke that whenever you pick up a rock, you find 5 technical guys that are zinc skeptics, and that's sort of a joke. And we're not zinc skeptics. That's me exaggerating for effect, but throughout the industry, everyone knows that top coated zinc and immersion has some technical funniness about it. To be frank with you, really good manufacturer marketing brought it to market, and it does work. And once again, let me reiterate, just so nobody gets it wrong. If you own a tank with zinc on it, it's fine. But the zinc's probably not doing any galvanic work right now, and you likely have 2 coats of epoxy on top of the zinc. So we're just arguing, why not 3 coats of epoxy? It's cheaper on a per gallon basis anyway. That's sort of our, I hope I answered your question there. But
Yeah, I think so.
It's marketing, frankly. I wish I could tell you there was some study that's been overturned. But
I'll add some historic context there, because I'll tell you, 20 years ago, I was having this conversation with some paint reps from another country another company that were marketing this technology to me as an applicator and buyer of coatings. And my question to them at that time was, hold on, my understanding of the corrosion cell is that there's gaseous output, right? So if I take zinc and I take a zinc coupon and I stick it in water and it's galvanically active and giving up electrons to protect the steel, you get this formation of bubbles around that steel coupon when you do that. And my question was, hey, if that's happening and it's in my coating system, isn't that a problem? Aren't we going to screw up the coating system? So even then, my point is 20 years ago, there was a lot of questions about, it doesn't seem like the zinc is really working, because if it was, we'd be observing these other phenomena and we just don't see them. Is this really working? I mean, again, 20 years ago, I was asking my paint reps the question, hey, it seems like this primer that I'm paying twice as much for isn't really doing what I think it would do, or maybe I just don't understand the corrosion cell. And I never got the right answer to that. And when I came to Induron as from being an applicator to being a paint rep for the first time in my life, that was one of the questions I asked at Induron, and I got a different answer. The answer at Induron was, we don't believe it is galvanically active. It works as a primer. It's got some barrier protection. It keeps the steel protected till we line it. So we don't have a problem with it, but it ain't galvanic. Bill getting to Induron is really what allowed us to do the science to write the paper and say, hey, we've all known for a long time this stuff isn't really galvanic when you top coat it and stick it in immersion, but let's take the time to prove it. And one of the hard parts of that is paint reps and paint manufacturing companies are generally not super likely to say, hey, stop buying this product from me and start buying that one that costs half as much. There just isn't a big economic motivation for paint manufacturers to make that pitch. And in our case, anyone that's familiar with Induron will know that we kind of eat, sleep, and breathe the term ceramic epoxy. That is our differentiator. It's what we live on. And knowing that we have ceramic epoxies that can match all these great application characteristics that people love with the MCU zincs, can actually deliver on all the technical promises and don't have those cost premiums or safety issues, is what's led Induron to say, hey, we don't mind being the coatings manufacturer that makes that argument. We do think the industry's better off moving to this other product, even if it is substantially less revenue per gallon for our company. And I think at the end of the day, that's the gap you're seeing is most paint manufacturers aren't interested in that conversation. They would like to just keep selling what they're selling rather than create a market shift.
I suppose from your perspective, it's one of those phenomenons where a rising tide lifts all boats, correct? Even if in the short term, there's a slight revenue hit because of the cost of zinc versus epoxy. If it's better for the overall industry, if it's better for the client, then in the long run, it's better for everybody involved, right?
We can serve our customer better if they're educated better and making an informed decision. Hey, if you own a water tank and you love zinc and that's what you know and you want to put zinc on it, please, by all means. I hope it's ours, like I said. But we want you to make that decision in full knowledge of what is happening and what's not happening with that zinc. And we don't want to just feed you a line to sell you some paint.
Right.
There's a lot of ways to paint a tank. A lot of them are valid, but we want you to know the truth.
All right. And as mentioned earlier, if our listeners want to access that white paper, the easiest way to do so is to go to materialsperformance.com/white-papers and search for Induron. I know that's not the only white paper that you've done or will do. That's the topic of our conversation today, but you guys have a lengthy backlog of them, and I know you have others in progress. Can you give us some insight on some other topics you're considering right now, and I suppose an early preview of what may be coming out in the future that people can go and read when it comes out?
Davies Hood and Andy have locked me in a dungeon, and they're not letting me out till I produce. So yeah, no, seriously. But right now we are working on a thorough review of the ASTM adhesion literature, and we're pretty excited about it. And I know that's not exactly the sexiest topic in the world, but there are a lot of standards for adhesion. ASTM D4541, pneumatic pull, 59, 6677. We can go on for years. How do we compare these? Imagine you're an engineer, you're a mechanical guy, you don't understand this paint stuff. You're building a tank. How am I to assess which coatings to use based on adhesion? This is one test here. This is one test here. Apples to oranges. How do I even compare those? Can you even in theory? And that's what we're looking to address here. Maybe not as radical or controversial of a paper as the zinc white paper, more of a review part paper, but I think the readership will appreciate it, the ones that care about coatings. Thanks for asking.
Yeah, I would say when we look at those future publications and stuff, you can almost find our thinking right in the title of Bill's paper, right? Questioning our assumptions. Everything we're saying about zinc and epoxy here is not, hey, stop buying zinc and no one should use it. It's question your assumptions. Let's make sure you're basing your decisions on all the real science we have today. And that's kind of the way we're looking at a lot of things. I'll give you another preview Bill didn't mention. A conversation I have, I feel like almost every day, is people's belief that epoxy just utterly melts in the sun. And their idea that, gosh, I can't put that epoxy on an open top tank. It'll fail in 6 months because epoxy can't have UV. So you start asking experts around the industry, how much will epoxy degrade in UV exposure in a year? And you will get some crazy, wildly different answers. And you tend to find that there's not a great source of information for those kind of things. So we look for stuff like that where we can say, wow, I asked applicators, engineers, a bunch of people in the market and got wildly different answers. There's inconsistent, market awareness around this topic, and it directly affects the products we sell. So those are the topics we try to look for ways to write a white paper, bring some valuable discussion, and kind of open everybody's eyes to the science we're able to do and how it can inform coatings decisions today.
Great insight there from Andy Odorzynski, National Sales Manager at Induron Protective Coatings, and of course, Bill Seawell, Technical Service Manager. If our listeners want to learn anything more about the company, simplest way is to visit Induron.com or go to materialsperformance.com/white-papers to access the white paper that we've been discussing throughout today's show and potentially some in the future as well, also known as the backlog, because they've been doing great white papers for a number of years. Gentlemen, before we close out, is there anything else that either of you would like to add?
Check out Induron.com. Our website's there. It's there. Got a lot of good stuff there. Don't want to go too into it now. It'll take forever, but great treasure trove of technical resources.
Absolutely. Thanks for taking the time, guys.
Thank you.
Go ahead, Andy.
Oh, I was just going to say, I'll back that up as well by saying we've worked really hard on interactive spec guides, a ton of video content on our YouTube page. We all work hard on the blog at Induron. Every person in the company is involved in it. So if you're interested in anything you heard here, I can promise you there's volumes more of us addressing and talking about these topics if you explore our social media and website.
Good stuff. All right, that will do it for today. For Bill and Andy, I'm Ben Dubose, news editor with the AMP Publications team. And if you want more resources from our end, you can check out our websites at amp.org for the association, ampp.org, that stands for the Association for Materials Protection and Performance. You can go to coatingspromag.com for Coatings Pro Magazine and materialsperformance.com for Materials Performance Magazine. And of course, check out the White Papers tab when you're there to access Induron's paper as well as others that we've published for years now and will continue to do for quite some time. All right, with those plugs complete, we will end things right here. Thanks as always for listening, and please come back soon for another new episode.